In this section, we'll be studying quadratic functions, and we'll see how we can take algebraic information and turn it into geometric information. We'll focus on studying the graph. The graph of a quadratic function is called a parabola. Let's go ahead and look at an example of a parabola. On the graph on the left-hand side, we have an example of a parabola that opens up. And in this section, we'll be interested in learning about different geometric properties of the parabola. For example, the first thing that we'll be looking at is how to identify the vertex of a given parabola. A vertex is the point on the parabola which is lowest when the parabola opens up, and when your parabola opens down, the vertex is the highest possible point. Other geometric properties that we'll be looking at are things we've seen in past sections, such as the x and y intercepts. In this picture, our x-intercepts are given by these green dots. And the y-intercepts given by this other green dot. The last piece of geometric information that we'll be looking at is the axis of symmetry. So the axis of symmetry is going to be a vertical line that intersects the vertex of your parabola. So this is the axis of symmetry. And the reason why we call this the axis of symmetry is because if we reflect our parabola across this line, then we get the same parabola. In this section, we'll be looking at two main objectives. The first, again, we want to translate quadratic functions into graphs, and the way that we're going to do this is we're going to be looking at different forms of our quadratic functions, taking this algebraic information and transforming it into geometric information. Then, in the second part of this section, we want to learn how to identify maximum and minimum values, and we'll be doing this by studying the vertices of a given parabola.